Ceramic Science presents
Atomic structure of water. In this video, we will see how to build atomic structures from the periodic table of elements, what one type of molecular bond is, and how to use this information to derive the basic atomic structure of water. We start by looking at a partial periodic table. We will zoom in to see the element hydrogen. The name of the element is at the bottom. The atomic symbol is the capital letter in the middle. Note that this symbol always starts with a capital letter, and if there are any other letters, they are all lowercase. In the upper right-hand corner is the atomic mass. Finally, in the upper left-hand corner is the atomic number. For us today, this is the most important part because it tells us the number of protons in one atom of that element. Not all periodic tables are laid out exactly like this, but they are usually fairly similar. In this example, we are looking at the element hydrogen. To understand the atomic structure of hydrogen, we need to know the number of protons and the number of electrons. All atoms, under normal circumstances, are neutral, meaning that they have a total charge of 0. The periodic table tells us the number of protons. Since we are assuming we are under normal circumstances and the total charge is 0, we must have the same number of electrons as protons. Think of it as electrons canceling out protons. Some atoms also have neutrons that do not affect the total charge, but for our simplified model, we will ignore neutrons. To draw a model of hydrogen, we start by drawing the single proton. The protons, along with any of the neutrons we are ignoring, form the central nucleus of the atom. Since we have only one electron, we can represent it by drawing an orbit for the electron to move around the nucleus on. While this model is somewhat simplified, it gives a fairly good first understanding of the structure of hydrogen. Unfortunately, not all atoms are so simple. Our next example will be a slightly more complex one, oxygen. The atomic number is in the upper left-hand corner of the box for oxygen on the periodic table is 8. So oxygen has 8 protons. We will assume that we have a total charge of 0, so there are also 8 electrons canceling out the 8 positively charged protons. We draw the 8 protons in the nucleus. Once again, we are leaving out the neutrons from our model of the nucleus. Now, to understand the orbits of the electrons, we need to look at the periodic table. Oxygen is in the second row, so there will be 2 orbits. Now we consider the 8 electrons. Think of each electron as corresponding to a single element. These electrons can be placed on the first 8 elements. Now the electrons in the first row go on the first orbit from the middle. Electrons in the second row go on the second orbit from the middle. For our purposes, we can assume that the electrons are roughly equally spaced out around the orbit. When we are done, we have a model of a single oxygen atom. If we look at the periodic table, the last column is called the noble gases. These elements are not chemically reactive, and so we can think of them as being happy. So happy, in fact, that they do not try to change their situation. Elements that are not in the last column are not happy and want to gain or lose electrons to get into the last column. For example, hydrogen would be happy if it could gain 1 electron. Oxygen does make it to the last column in the first row, but needs to gain 2 electrons in the second row to be happy. So hydrogen wants 1 electron, and oxygen wants 2 electrons. If hydrogen shares 1 pair of electrons with oxygen, then hydrogen becomes happy. Oxygen is still not happy, but it now only needs 1 more electron instead of 2. So if we bring in another hydrogen atom, that hydrogen atom is unhappy, but will become happy if it also shares a pair of electrons with oxygen. Now oxygen is happy, and both of the hydrogens are happy. We call this sharing of electrons a covalent bond. Instead of drawing this full model, we will usually represent each element with its atomic symbol and add lines to represent the bonds. The 2 hydrogen atoms and 1 oxygen atom, along with the bonds that hold them together, form a molecule. In this case, the molecule is a single molecule of water. In our next video, we will talk about why we draw the water molecules with the hydrogen atoms at an angle, how the angle affects the physical properties of water, and why that angle makes water the most important molecule on Earth. I hope you'll join me then.